Hello, welcome. Today you are going to learn the continuation of properties of parallelograms. Already some properties in the form of theorems already you have learnt, and today you are going to learn some more properties in the form of theorems. And today's theorem is, if two pairs of opposite angles of a quadrilateral are equal, then it is a parallelogram. That means if in a quadrilateral both the pairs of opposite angles are equal, then it is a quadrilateral. Clear? We don't know whether it is parallelogram or not. It is a quadrilateral. Let me name this as ABCD. Angle A is equal to angle C. Angle B is equal to angle D. If two pairs of opposite or both the pairs of opposite angles of a quadrilateral are equal, if these two are equal, we have to prove that it is a parallelogram. Okay? How to prove it? That means what is given is ABCD is a quadrilateral given, is a quadrilateral in which angle A is equal to angle C, angle B is equal to angle D. That is given to you, and you have to prove that ABCD is a parallelogram. How to prove it? Okay? You know that whatever may be the quadrilateral, the sum of four angles of the quadrilateral is 180 degree. Angle A plus angle B plus angle C plus angle D is 180 degree. Angle A plus angle B plus angle C plus angle D is 360 degree. Sum of four angles of a quadrilateral is 360 degree. But we know that angle A equal to angle C, angle B equal to angle D. So angle A plus angle B. In place of C, let me write angle A. In place of D, let me write angle B. Any problem? I am not giving you the reasons. So 2 angle A plus B equal to 360 degree. That means angle A plus angle A plus angle B equal to 360 degree by 2, that is 180 degree. Angle A and angle B are co-interior angles. Angle A and angle B are supplementary 180 degree, and they are co-interior angles. If a pair of co-interior angles are supplementary, that means if the sum is 180 degree, then they are parallel. That implies AD is parallel to BC. AD, if these two, sum of these two is 180 degree, these two are parallel lines. Similarly, you can show that angle B plus angle C, that means in place of A you can write angle C. Okay? In place of D, angle B, we will get angle B plus C. 180 means AB parallel to DC. AB is parallel to DC. And already you have learned that if both the pairs of opposite sides of a quadrilateral are parallel, it is a parallelogram. These two are parallel, these two are parallel. Therefore, ABCD is a parallelogram. That is proved. So this is the property is, if in a quadrilateral both the pairs of opposite angles are equal, then it is a parallelogram. Okay? Now, let us have one more theorem. Okay? If one pair of opposite sides of a quadrilateral are equal and parallel, then it is a parallelogram. The theorem is, if a pair of opposite sides of a quadrilateral is equal and parallel, then it is a parallelogram. That means ABCD is a quadrilateral. If AB is parallel to DC, AB is equal to DC, then ABCD is a parallelogram. That is already proved and it became a theorem. But let me prove it. So what is given to us is, in the quadrilateral ABCD, what is given? AB is equal to DC and AB is parallel to DC. That is given. We have to prove that ABCD is a parallelogram. ABCD is a parallelogram. You have to join either AC or BD. That is in construction step. You can do that. Construction is join AC. Now how to prove it? I hope you got it. Let us make these two triangles congruent. Can we make them congruent or not? Already AB is equal to DC given and these two are parallel given. So these two are interior alternate angles. If these two are interior alternate angles and AC is common to both, then these two triangles are congruent. If these two triangles are congruent, by CPCTC, we can show that this angle is equal to this angle. But they are interior alternate angles. If a pair of interior alternate angles are equal, the lines are parallel. So AD will be parallel to BC. AB is parallel to DC already given. AD will be parallel to BC, you will get. So ABCD is a parallelogram. Okay? In triangle ABC and the triangle ADC, what is given? AB equal to DC given. AC is equal to AC, that is common side. And angle BAC is equal to angle ACD. They are interior alternate angles. Therefore, triangle ABC is congruent to triangle ADC under SAS condition. If they are congruent, therefore, let us show angle ACB is equal to angle DAC. That is by CPCTC. But they are interior alternate angles. If a pair of interior alternate angles are equal, the lines are parallel. That implies AD is parallel to BC. Okay? And we know that AB is parallel to DC, we know, given. Or it is given that AB is parallel to DC. We got AD is parallel to BC. Therefore, ABCD is a parallelogram. Okay, the theorem is proved. Theorem is clear? So these are the two properties. If you know that in a quadrilateral, one pair of opposite sides are equal and parallel, the quadrilateral is a parallelogram. Clear? Please go through and make the concept clear. Try to understand, and these properties are very, very important. So try to remember these. Thank you.